Hi everyone. In this lesson we're going to continue solving quadratic equations by factoring. To solve quadratic equations by factoring, we need to be able to do two things. First, we need to be able to factor trinomials, and then we have to apply the zero product rule. This rule says that if you have two quantities that are multiplied to a product of 0, then the first quantity must be equal to 0, or the second quantity must be equal to 0. So if A and B, A times B is equal to 0, then A must be equal to 0, or B must be equal to 0, because that will be the only way to get this multiplication equal to 0. In the last lesson, we did the simple equations similar to what we have here in number 5, number 4, and also in number 6. What we have here in number 6 is the simplest case where you already have a 0 on the right side, and then you just need to factor the trinomial. And since you will have two factors being multiplied to get a 0, you will apply the zero product rule. In the case of number 4 and number 5, we need to move everything that is on the right side to the left side to leave a 0 on the right side, and then you will do the same thing. You will factor the trinomial that you have on the left side and then apply the zero product rule. The same thing for number 5. Move everything to the left side and then factor and apply the zero product rule. Today, however, we're doing exercises that look like number 1, number 2, and number 3, which look a little bit different. So we're going to see how we solve them. In the first example, we have x multiplied by x minus 2 equal to 15. One thing that we have to be very careful here is that you cannot say this. You cannot say that because the multiplication of these two quantities is equal to 15, then x must be equal to 15, or x minus 2 had to be equal to 15. That is absolutely incorrect, because this rule that I have right here, that's only when you have a product equal to 0. That's why it's called the zero product rule. The result of the multiplication must be 0. Then you could say the first factor is equal to 0, or the second factor is equal to 0. Not in this case, because we have a product, yes, we have a multiplication, but it's not equal to 0. So this is something that we cannot do. Okay, what we do in this case is the following. We multiply with the distributive property, the x times the x, and then the x times the negative 2. So we will get here x times x squared, x times negative 2, negative 2x, and that is equal to 15. So now I can do what we did on the last lesson. I can move this 15 to the other side in order to have a 0 here. But we have to remember that whenever we move something from one side to the other side of the equal sign, we have to use the inverse operation. Here the 15 is a positive. On the other side, it has to go subtracting. So it's going to be x squared minus 2x minus 15 is equal to 0, because everything was moved to the other side. We have nothing left on the right side, so it is equal to 0. And now we can factor the trinomial. And we know that a trinomial comes from the multiplication of two binomials. we need an x and an x to get the x squared. And then we look for two numbers that multiply to -15 and that add to -2. Those two numbers must be -5 and +3, because if we multiply those two numbers, we get -15, and if we combine these two numbers, we get -2. So now we have a product, a multiplication of two quantities that is equal to 0. Now we can apply the zero product rule. So if x minus 5 multiplied by x plus 3 is equal to 0, then x minus 5 must be 0, or x plus 3 must be 0. And now we solve each of these simple linear equations. We are also using the inverse operations. I need to move this -5 to the other side. It should go adding on the other side, or we simply add 5 on both sides. So that gives me x is equal to 5, because 0 plus 5 is 5. On the other equation, I have an addition, so I need to use subtraction. Subtract 3 and subtract 3 on the other side. That gives me x is equal to -3, because 0 minus 3 is -3. So these two are the solutions, but we have to check. Whenever we solve an equation, we need to check the solutions that we get to make sure that they are correct. So we're going to do the check for both solutions. We're going to check first x is equal to 5, and then we will check x is equal to -3. We take our original equation, substitute all the x's by 5, and we simplify the right side and the left side. So after we substitute, I'm going to start by writing the original equation. And then I'm going to substitute the x by 5, all the x's by 5. And now I simplify the left side. Simplifying the left side, I have 5 minus 2, that is 3. 3 should be multiplied by 5, and that should be equal to 15, and that is actually 15. 3 times 5 is 15, so you have both sides equal to 15. Therefore, this solution, x is equal to 5, is correct. And now I'm going to check the second solution, x is equal to -3. So again, I do the same thing. I start with the original equation always. Substitute the x, in this case, by -3. All the x's by -3. Simplify inside the parentheses, that will be -5. And that should be multiplied by -3. And that should be equal to 15. And -3 times -5 is 15. And I have 15 on the right side as well. So I have both sides equal, and therefore this solution is correct, because whenever we're solving an equation, we're looking for those values of x that make the right side equal to the left side. So we want the left side to be equal to 15, so that both sides are equal, and that is what 5 does, and that is what -3 does. So these are the solutions. Solutions 5 and -3. This is not a point, so we should not use parentheses here. Number 2 is obviously the same process. I'm going to multiply x times x. That gives me x squared. X times -12, and that gives me -12x. And now I'm also going to move the -35 to the other side, so I avoid doing one step. So I'm going to bring the 35 to the left side, and it's going to become +35. And so I'm going to end up with a 0 on the right side. So I have 2 steps here done. And now we factor this trinomial. A trinomial is always coming from the multiplication of 2 binomials. X times x for x squared. And now we look for 2 numbers that multiply to +35 and that combine to -12. Since this is positive, these 2 numbers will have to be both negative or both positive for the product to be +35. But since I have the middle term of the trinomial negative, that's telling me that it has to be both negative here. And the numbers that we're looking for are 7 times 5. Those 2 numbers, -7 times -5, multiplied to +35, and they combine to -12. And now that I have a multiplication that is equal to 0, now I apply the zero product rule. If this multiplication is equal to 0, then x minus 7 must be equal to 0, or x minus 5 must be equal to 0. I add 7 to both sides on the first equation to solve for x. So x is equal to 7, because 0 plus 7 is 7. On the second equation, I need to add 5 on both sides to solve for x. And that gives me x is equal to 5, because 0 plus 5 is equal to 5. So these would be the solutions here. Seven and 5. I'm not going to do the check here only because I don't have a space. Or maybe I should erase what I have over here. That's what I'm going to do. I'm going to erase what I have here, and I'm going to do the check. So the check has to be again with both solutions. We want to make sure that both solutions are correct. So we are going to start by checking x is equal to 7. Write the original equation, which is x times x minus 12 equal to -35. Replace all the x's by 7 in this case. Simplify the left side. Inside the parentheses, 7 minus 12, that is -5. And that should be multiplied by 7, and that should give us -35. And yes, it is -35 because 7 times -5 is -35. And so we have both sides equal. That is telling us that the solution x is equal to 7 is correct, because that's what a solution does. It makes both sides equal. Now I'm checking x is equal to 5. Start with the original equation. Substitute all the x's by 5 in this case. Simplify the left side. Inside the parentheses, that is -7. 5 minus 12 is -7, which should be multiplied by 5, and that is supposed to give us -35. And yes, it is -35. 5 times -7 is -35. And on the right side, we also have -35. Both sides are equal, and that proves that our solution x is equal to 5 is correct. So this is what you have to do for exercises 1, 2, and 3 down here, which you're going to complete. And 4, 5, and 6, they are similar to the ones that we did on the last lesson. So that is for the lesson for today on solving quadratic equations by factoring in our day number 2.